like to thank the OMICS Group, the very efficient group, where they have shown a very good interest in this organization of this symposium, because I know A to Z about this group, because I am associated with them right from the beginning of this symposium. Now, I'll start my talk and I'll complete my talk, and after my talk, it's my duty to talk something about the concluding part of this session. Because whatever I have observed, I am going to talk here, and that may be a message to you, or it may not be a message to you. But it's my duty to talk something about the concluding part of this session. The topic, Dr. Ryan, I have decided this topic because most of the people, they are talking about the medicinal plants and all. No doubt, I have edited some 50 books on medicinal plants, but I am not talking about medicinal plants because most of my friends of scientific community, they can talk about that part. The part which I am going to talk, it is somewhat different, but at the same time, it is somewhat important also. Unless and until we know the basics of biostatistics, we will not be in a position to compile our data in a very, very systematic way. That's what I have observed during this session, which I am going to talk about after this talk. Now, the first slide of my talk, that is the schematic map of the presentation, is the measures of central tendency and dispersion, the introduction, arithmetic mean, the variance, the standard deviation, the standard error of mean, the coefficient of variation, the t-test and the LST test. Most of the students of these days, they are using only these basic methods, but if they know this point, they can use in a much better way as compared to what they are talking but not showing. The formula used here, the mean, I think you may be knowing, x bar sum of x divided by n, the variance, the s square, if you put it as capital S square, it will be the population variance. So be the scientist of biology or zoology or botany, we should be very particular about this point because we are talking about the sample, not the population. Now the second point is sum of x minus x bar whole square divided by n minus 1. That depends on 30 or more than 30 observations. The standard deviation, the square root of the variance, then come to the standard error of the mean, the standard deviation and under root of n, then coefficient of variation, where somebody was talking very high coefficient of variation, which I am going to talk right now in my discussion. Then test of significance, then we will come to the last part, that is very, very important part, where we are going to compare the two treatments. That is the least significant difference at the alpha level. Now, you can see the introductory part of this talk. The data you know, all of you know very well. The first important part of the biostatistics is the data collection. It may be, the data may be the primary data or the secondary data. The second part, come to the next, that is the parameter. That parameter may be, you can say, you can talk in respect of any variable where the numerical quantity which characterize a population is called parameters of the population. So this parameter comes after data. The next part is variable. They may be categorized as quantitative variables or qualitative variables. Most of them, they were presenting about these quantitative variables. Population. You see, when we talk about the population, all plants of a variety of wheat present in 1 acre of land referred to as population. Similarly, you can talk about the fishes in a pond, or you can talk about the hospital, the patient of a hospital. Sample, you know, in our day-to-day life, we are talking about sample, that is the sampling techniques almost every moment of our existence. You see, when we select few items from the population in such a way that they are representative of the population, such section of the population is called as sample, and the process is known as sampling. The next part is size of the sample, which is very, very important. Sometimes we talk less than 30, sometimes we talk more than 30, but sample should be optimum in one way which fulfills the requirements of efficiency, effectiveness, reliability, and flexibility. Now, the sample, when we are talking about sample, you should be very, very careful. If it is less than 30, we have to use a correction factor that is n minus 1. Clinical trials. Though this subject is somewhat controversial because sometimes we talk about more subjects, sometimes about less subjects, but they don't agree with this. Those who are performing the clinical trials, they don't go as per the single blind study or the double blind study. In single blind study, you know very well, the patient does not know whether he or she is in the same treatment or in the control group. Similarly, you talk about the double-blind study in which neither the patient nor the experimenter knows to which group the patient is assigned. Now, the next part is the basics of clinical trials. Now, you see the phases of clinical trials. The zero phase where, my friends, they are not taken into consideration, that is also a phase where we can take the subject 10 to 15. The first trial where we have to find out the experimental drug or a treatment in a small group of people, 20 to 80. Second trial, 100 to 300. Third trial, 1000 to 3000. Later on, we have to go for FDA. But unfortunately, my colleagues, my friends, they are coming only to this part of the clinical trials. They are not proceeding to this group or this trial or this phase, so I am not going to discuss more about this part. Measures of central tendency. You know, we have seen there are situations where it requires other type of summarization. Measures of central tendency is nothing, but we have to find out one single value. Then later on, we have to find out the spread of the variability on either side of the single value, that is the dispersion. That is the dispersion. I have already told you the measures of dispersion are range, mean, variance, standard deviation, arithmetic mean. Now our talk will start from this part because this is only the part where we are talking about the calculations. You see, this is very simple calculation where we have to sum up all the observations divided by number of observations. You can get the mean. Nothing is there new to talk more about this. But this part of the problem is important because this is the application part where we have taken the oral glucose tolerance test of Costas pictus leaves, methanolic extract and its fractions. Because in this case what we have seen, the problem where we have seen here, the Costas pictus methanolic extract 200, 500, hexane fraction 200, 500, ethyl acetate fraction 25, where we have seen this is the fasting, very important drug, metformin, where we are seeing all the values they are decreasing. When we come to 60 minutes, 90 minutes and 120 minutes, we are seeing only this part, which is very important, the last part 500, here only up to 90, we are getting the reduction at significant level 5%. Now come to the other part of this problem where we are seeing this is also a very important part. So my point here is, if you want to proceed further, you can take these points into consideration for the future generations. We have already concluded this part. Variance, you know, this is given in 1913 by R.A. Fisher. This is nothing but the mean of squares of deviations. You can check up here the sample variance. I have already told you. The population variance I have told you. If you want to check this part of the problem, you can apply this formula: S square sum of x square minus sum of x whole square divided by n, the whole divided by n minus 1. You can see one problem how to calculate. You just take the observation sum of x square, and you go to the formula, you can get the answer. This is the part which I want to talk, because this is the application part. Here I have taken the mean plus minus standard error of the mean and the variability and shift in mean of the plant yield in up to generation. Here I have taken this part 20 kr, 2.2 kr, 2% EMS, 0.2% LMU, where I have seen the mean values. They are showing quite impressive trend, but this value where we are seeing that the variability is less, shift in mean is more, though the value is significant. So based on this observation, we have proceeded further to the next part, and the next part is the standard deviation. That is the point where the Carl Pearson has given in 1893. The square root of the variance is the standard deviation. You can calculate, just now you have seen the variance, you can see the standard deviation, and you can calculate, but this part of the variability or the variance, standard deviation, is more important. You can see here at the dispersion of the variability. What is this? The standard deviation, greater the value of the standard deviation, the variability will be more there in the population. That will not be good for a scientist to proceed with the same findings. You see the example here. We have seen this. This deviation is the standard error. The smaller the standard error, the more representative the sample will be of the overall population. The standard error is also inversely proportional to the sample size. Larger the size of the sample, the smaller is the standard error. We should concentrate more on the larger side, but not on the smaller size of the sample. That will not give you correct values. Whereas in case where the standard error will be more, in small samples, your significance label will not be there. For what we are trying for significance label, we will not be getting if the standard error is more. You see here, when we talk about mean, variance, standard where this is standard deviation and standard error of mean, we have already discussed these calculations. Now, we are very particular about the mean values. You just see the effect of semicarpus, anacardium, linseed extract on ethanolic-induced gastric ulcers in rats. We have seen in control omeprazole and SAAE, I have already given here, SAEE and SAPE, where we have seen the control, where the value of the control, where in this case, third case, the same value is there, but unfortunately this value is non-significant because of the fact that the standard error is quite high. In the same way, we are getting here this percentage protection from ulcer is also not there. Here in this case, we have the mean values more or less same in this case, and here in this case, where we are getting percentage protection from ulcer 78 to 71%, here also 71%, whereas the highest value of the protection we got here with the highest significance level, in this case we are 87%. But I should give you one message that you can conduct your future experiment based on this part and this part, second experiment on this part, but third experiment where one should not be careful enough. This is the most important part of this problem, where we should concentrate more on minus 8.33, because we have to find out in future generations whether we are getting any recovery index or not. Because that recovery index at any stage, wherever we are going to get, that will be something new in your findings. So my small message to you all is, don't discard this value, these type of values. They are equally important as compared to other values, because this minus value is more important here in this application as compared to all other values. If I am a scientist on this aspect, I will not consider the values other than the value which I am talking more and more here, because we can get something very important here at the stage where the recovery index we have to see. Coefficient of variation. Here the coefficient of variation is nothing, the standard deviation divided by mean and into 100, because always we have to calculate the standard deviation in percentage. Lesser the standard deviation, more reliable value will be there, homogeneity will be more, and the effectiveness will be more, variability will be less, means it is good for the scientist to proceed further with the lesser value as compared to the more value, as some of my friends was talking about high value of coefficient of variation that is not required in breeding experiment. Either it may be mutation breeding, plant breeding, or any type of experiment when we talk about breeding. I'll be talking about next part of the application. Here I have taken two types of drugs on 10 patients for reducing their weight. Drug A was imported and drug B was indigenous. The decrease in the weight after use of drug for 6 months is as follows. Actually, this is a project from Government of India, but my friend did not disclose the name of the drug, what drug he is going to use for this project. He simply gave me these values. So on the basis of these values, keeping in view drug A, drug B, instead of the name the drug may be anything, because drug may be any type, because he did not disclose, because this is the project from Government of India, so he cannot disclose the name of the drug. So based on the drug A and drug B, I have calculated, then I have concluded the problem. You can check up here drug A, drug B, where I have calculated the mean, variance, standard deviation, standard error, and CV. In both the cases, I have calculated. Here the two important points are there. The mean value, you see whether it is high or less. You see here. But we are very particular about coefficient of variation. Here it is 12.14, here it is 9.22. So the concluding part of the problem is the mean weight reduced by drug A is higher than the drug B. However, the coefficient of variation is also higher for the drug A than the drug B. It clearly indicates that the drug B, indigenous, is more consistent or homogeneous than the drug A, imported, because the coefficient of variation is less than the drug A. So the part is, we should always concentrate on this part. It should be always less. If it is more, you will be losing somewhere something. Your experiment will not give you correct values. Test of significance. I'll tell you some small point about this test of significance. So far we have this standard deviation of 9 and 3%. Estimate the mean of the blood sugar glucose level with 95% confidence levels. You see, this is the confidence level, this is the standard deviation, number of observations, standard error of mean, I got 2.85. Degrees of freedom, table value that you can see from the books, T value at 5%, at 9 degree of freedom, 2.26. 96 plus minus 2.26, that is 2.85 equal 96 plus minus 6.44, that will be equal to 89.56 to 102.44 mg. That should be the range of the sugar level in any patient of the sugar. Paired t-test, unpaired t-test, everybody knows about it. How to find out this formula of t-test? The upper part of the formula, difference between the mean, the lower part is the standard error of the difference. This, lastly, we got this formula, and this is either you take any treatment or number one, control, then the treatment, and the number of treatment, number of observations, then the control, number of observations for the control. You see one problem where we have taken boys mean weight 54 kg, variance 16, girls this much. Calculate the value of T for these two parameters, two sets of data, and with the help of this formula we have calculated, and we got 5.93, the value of the calculated value, T value 5, we got 5.93, tabulated value at 5%, 2.0.021, and degrees of freedom here. The calculated value of T at 5% is 5.93, which is bigger than the tabulated value, both at 5% and 1% levels of probability. There is indeed a significant difference between means of two sets of data. This also rejects the null hypothesis that there is no difference of means. This is the most important part for any two type of calculation: control of the treatment, treatment 1, treatment 2, because most of my friends, they were talking about more treatments. So this type of problem or this type of calculation is very important, that is known as least significant difference. If I am not wrong, for the first time we have given this part of the problem, or this least significant difference in, not a very small scale, but many problems we have given in our book, that is Fundamentals of Biostatistics, written by me and another author is sitting there. It's a very popular book in pharmacy colleges, biology departments, and any biology or environmental sciences where I am having, I should not talk, because this book is not less than 10 lakhs rupees sale per annum. This is very, very popular book in India. Pharmacy colleges, yes, he is sitting here, you can ask this person, without this book can he go through the examination or not. Now the next part of the problem is, now we have to explain, then we have to talk about this calculation. So I'll move to the calculation part, the last part of the calculation, that is the last part of the presentation, where I have taken in an experiment, fresh weight of the plant was recorded for control and 5 doses of the chemical treatment, mutagen. Compare the mean fresh weight of control and 5 doses. This is the problem, how to calculate. I'll discuss more about this part. Here I have seen the doses: control 0.1, 0.2, 0.3, 0.4 and 0.5% EMS, and this is the fresh weight in grams, and this is the standard error of these mean values. These mean values, just now I was talking about Dr. Susila, she was talking but not showing. I told her, please show the significance level. Difference from the control, they are the values, they are showing the difference from the control, the treatment values, where the non-significant, significant, 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 and non-significant, and this is a LSD value at 5%, 1%. I have given the hint here, 10 kr, this you can calculate here. You say, for example, 5%, this value you can calculate here, 1.960 and 0.7241, you will get some value, and on the basis of that value, in this style you can calculate these values, and you can compare whether the difference from, you can see here, this part and this part, and you can compare The difference between control and different doses indicate that the 0.2% and 0.4% EMF doses are highly significant, whereas 0.1% and 0.5% doses are not significant. So this is the part of my discussion, of my talk, and as all of you are talking about the concluding part of the problem, but my concluding part of the problem is different. Einstein quotation will be there. Try not to become a man of success, but a man of value, given by Einstein. And the last part is, thank you very much for hearing me out. Thank you very much.